Good morning, everyone. Very good morning, Shreya. Good morning. Good morning, Anjali. So, we have to start with the next part, which is transformation of the equation in variable separable. So, what kind of equations I can transform? At a first glance, or you just need to do some simplifications in these kind of equations. So, if you have this, I'll count as method 1A. Method 1A. Right? Transformation of equation in variable separable form. All right. So you see, whenever you have dy by dx of this form, if you have a function in ax plus by plus c divided by another function of ax plus by, this may not look like that you can separate the variables, but in actual, with a simple substitution you can do that. Substitution is put ax plus by plus c is equals to t. With this substitution you can uh, transform it into the variable separable. Let's see a question. Question number 1. Right? Solve dy by dx is equals to this whole square. So again, this is dy by dx, and as you can see, there is a function of ax plus by plus c in the numerator, and in the denominator is a constant function. So basically, if you compare it with the f of ax plus by plus c divided by g of ax plus by. So what is f of x and what is g of x here? Then f of x is x square and g of x is 1. Right? I hope you can see that, because when we have substituted this for ax plus by plus c in the function, then it is x square. So, and it is the same function of this in the denominator also. So there is no problem. What substitution we need to do? We need to just substitute this entire as t. So, acha. Also make sure that first of all it is not variable separable. Then why are we applying this condition if it is already variable separable? So you observe that is not possible. I cannot separate the variables right now. So, but this substitution will help us. Put 4x plus y plus 1 is equals to t. It implies 4 plus dy by dx is equals to dt by dx. Right? Which implies dy by dx is equals to dt by dx minus 4. Substitute. Therefore, therefore differential equation becomes dt by dx minus 4 is equals to t square. So which further implies dt by dx is equals to t square plus 4, and now you can see it's variable. We can separate the variables. 1 by t square plus 4 dt is equals to dx. So this is 2 square, right? And it will become, we need a 2 here and 1 by 2 here. So it becomes, by integration, 1 by 2 tan 1 by 2 integration of 2 by t square plus 2 square dt is equals to integration of this. This gives us, it gives us 1 by 2 tan inverse t by 2 is equals to x plus c. Substitute the value of t. So therefore 1 by 2 tan inverse 4x plus y plus 1 upon t upon 2 is equals to x plus c. That is your answer. Next. This is also same kind of question. X plus y whole square dy by dx is equals to a square. Now if you find dy by dx is equals to a square by x plus y square, this time function f is constant and g is x square. Okay. So, but you see, you usually substitute x plus, means whatever you have f of this domain, this you substitute as t. So what would happen here? First of all, comparison is not very difficult. I can remove this a square, or I can assume this to be a square. f of ax plus by plus c is a square, and g of, so in particular in this question it is just x plus y I can take, right? Because for g we have x plus y, g of x plus y is x plus y whole square, right? Acha, now you substitute this as t, right? So let us substitute c as 0. The reason being because that input is not affecting my output. Output is a constant function. So in fx is equals to 3 function, no matter what is your input, no matter what is the value of x, output is also 3. So value of the function will not change even if I take this c to be 0. So the complete input over here becomes x plus y only. So put x plus y as t. One plus dy by dx is equals to dt by dx, which implies dy by dx is equals to dt by dx minus 1. All right. Now substitute. So differential equation becomes dt by dx minus 1 is equals to a square by t square. So dt by dx is equals to a square plus t square divided by t square. It becomes a dt t square divided by a square plus t square is equals to dx. How to solve it? You just add and subtract t square here and integrate. If you add, add and subtract a square. So when you add a square, it will get cancelled 1 dt. When you subtract a square, minus a square divided by t square. So 1a I can take outside. T square plus a square dt is equal to integration of dx. So it becomes t minus a times tan inverse t by a is equals to x plus c. Substitute your value of t as x plus y. So x plus y minus a tan inverse x plus y divided by a is equals to x plus c. That is your answer. Try to leave your answer only, means if it is possible, not much of a calculation or simplification is required. So please try to leave your answer with c constant, means with the value of c. I haven't done in most of the questions so far, but you always try. For example, over here, you just take this x this side. That will be useful actually. We have to do such questions in which we require that c in terms of x and y. Just a normal habit to leave the final answer. If you can give the answer the picture in which this constant is given, then it's better. If it's very complex, you can't do that, just leave it. Okay, that doesn't affect the answer. All right, next, method number 2 comes homogeneous equation. After it is being observed that it's not variable separable, I cannot separate the variables, I cannot reduce it to variable separable, then the next thing I'll check in my equations whether it is homogeneous equation or not. Because to solve homogeneous equations, please note, we are only looking for first degree and first order. Yes, we do have homogeneous in second order, second degree, and that, but that is different. Every discussion we are doing only in the first degree and first order. Acha. Now, first of all, what is homogeneous differential equation in first degree and first order, and how to solve it? So this is easy. If you have dy by dx, you find out, and you can write that as a function of, as you can see, f of y by x. What does that mean? We'll see that in a question. But once you have that, once you know that it is a homogeneous equation, these kind of equations we solved in differential equation in class 12th also. And in fact, this is the major section of class 12th in differential equation, homogeneous equations. So what do? We put y by x, or you can write, we put y is equals to vx, differentiate both sides. So this is the method. Let's see. First of all, how you will check whether it's a homogeneous or not. This is question number 3. Solve this. Okay, it's already written in this form, but no. Everywhere, whenever I see x, that should be in the denominator. We should have y. Means everywhere we should have an expression of y by x. This x and this y is not allowed. Okay, so let's see whether we can write that or not. So let's try to find dy by dx from here. Here dy by dx is given. So dy by dx is equals to. So you take this part, okay, this part over here, this as it is. So I'm taking that y inside, right? So it becomes xy cos y by x plus y square sine y by x divided by this part. So I'm taking this also xy sine y by x mm, plus this is minus. Acha, no, this is minus x square cos y by x. Right now I cannot say that it's a homogeneous because of these. If I see x and y in the function, then it always has to be of the form y by x. What I can do? You can just divide by x square both in the numerator or denominator, or you take x square common. If you take x square, no, if you take common, then you have to take y by x. Okay, x square can be taken common. So if I take x square common from here, it becomes y by x cos y by x plus y by x whole square sin y by x divided by here again y by x. Now I can say that it's a homogeneous equation minus cos y by x. Okay, so once you have everywhere the expression y by x left, now what else? Now put y is equals to vx. Put y is equals to vx. So dy by dx is dy by dx is equals to v plus x dy by dx. Equation 1 becomes v plus x dv by dx is equals to, now if y is equals to vx, then you can see y by x is v, so this will change into v cos v plus v square sine v divided by v sine v minus cos v. Let's take this v this side, so it's x dv by dx is equals to v cos v plus v square sine v minus minus v square sine v plus v cos v. Cancel, divided by v sine v minus cos v. dy by dx is equals to, so this becomes 2v cos v divided by v sine v minus cos v. Okay, now separate the variables. V sine v minus cos v divided by 2v cos v is equal dv is equals to Let's take that 2 over here. 2 by x dx. So this becomes sine by cos tan integration minus log cos of v, and minus 1 by v, so minus log of v. So I can take log of c also this side, and here it will be 2 log x. Find out c. This is c divided by v cos v is equals to x square. So c is x square, and what was v? V is y by x. So y by x cos y by x. This is equals to xy cos y by x. This is the next part where you find where you don't have homogeneous differential equation, but you can definitely reduce it. Okay, how? See, I'll not explain this here. Through a question, we'll see what is given here, and look at the equation. Equation is of this form now. It's a polynomial in terms of xy and a polynomial in xy, and it's a linear polynomial in xy. Now, it's not any function. You can't have any function. It has to be a linear polynomial in two variables x and y, both in the numerator and denominator, where this should be true. Okay. Chalo. Actually, this condition must remind you about finding equation, solving these two. We used to check whether they are intersecting lines or parallel lines or coincident lines. We don't find solution in parallel or intersecting line or coincident lines. We only find it in this, and that is the condition. If two lines are intersecting, that is the condition: a by a dash, b by b dash. So why do we need that? Let's see through a question. Question number 4. What does the question says? Question says dy by dx plus x minus y minus 2 divided by So it is a kind of an equation in which it can be reducible to homogeneous. How? First of all, you write the required form. So dy by dx is equals to minus x plus y plus 2 divided by x minus 2y minus 3. Acha, next, they are saying small x, substitute small x as capital X plus h, small y as capital Y plus k. Let's do that. So put small x as capital X plus h and small y as capital Y plus k. So what is d uh, small dx is capital X? What you need to do now is differentiate both sides with respect to capital X. If let's say, so that means this is dx by dx is equals to 1. So it implies dx is equals to dx, right? Similarly, you will get dy is equals to dy. So here this will be exactly changed to d of y divided by d of x. And here you will have the substitutions. So first becomes differential equation 1 becomes dy by dx is equals to minus capital X minus h plus y plus k plus 2 divided by capital X plus h minus 2y minus 2k minus 3. Alright. dy by dx can be written as minus x plus y, and then minus h plus k plus 2 is the constant, divided by x minus 2y plus h minus 2k minus 3. Now look at this. Yeah. So equation 3 becomes this. See, this is the exact form I have given to my equation. Right? In the bracket, I have taken those constants, h, k, and the constants. So this is it. In order to make equation number 4 homogeneous, choose h and k so as to satisfy the following two equations. Basically, you have to choose h and k such that these constants become 0. So you have to solve. So choose h and k such that minus h plus k plus h plus 2 is equals to 0 and h minus 2k minus 3 is equals to 0. Adding them, minus k minus 1 is equals to 0. So k is minus 1. Substitute. It implies minus h minus 1 plus 2 is equals to 0, which implies h is equals to 1. So you have h1 and k minus 1. Okay. Now, therefore 2 becomes therefore equation 2 becomes dy by dx is equals to minus x plus y and 0. You don't have to substitute. You know that the way you have chosen the values are making this and this 0. Okay, so given that your calculations are correct, so it is 0. You don't have to substitute. This becomes this x minus 2y. Now what you can do, it is not of the form y by x. You take x common from numerator and denominator, cancel out. So you will be left with minus 1 plus y by x divided by 1 minus 2 y by x. Okay. Now substitute y is equals to vx, right? So again, dy by dx is equals to v plus x dv by dx. Substitute, so it implies v plus x dv by dx will be equals to minus 1 plus y by x is v, 1 plus v, 1 minus 2v. I'll take that v this side. So x dv by dx. These kind of questions where we have to solve homogeneous equations are these kind of questions are filled in the NCRT differential equation. So even if you remembers only the basics, how the integration works and everything, this is easy. Minus 1 plus v minus v plus 2v squared divided by 1 minus 2v. So x dv by dx, this gets cancelled, and it is minus 1 plus 2v squared divided by 1 minus 2v. Separate the variables. This is 1 minus 2v divided by 2v square minus 1. dv is equals to 1 by x dx. How to do this integration? Separate, first of all. This is 1 upon, take 2 common. It becomes v square minus 1 by root 2 square dv, right? And minus again, let's say 1 by 2 common here, and 2v divided by v square minus 1 by 2 square minus 1 by 2 dv is equals to 1 by, this is log x, 1 by x log x, right? What is this? 1 upon, this is not plus, it's not tan inverse, it is the log formula, right? So 1 by 2 is outside, but that is 1 minus v square, so I can take minus common. Minus 1 by 2, that becomes 1 by root 2 a square minus x square, right? So formula is this, right? 1 by a square minus x square dx is equals to 1 by 2, I think a by 2 and log of a plus x divided by a minus x. Just do verify this is the formula or not. 1 by 2a plus and minus, this is 1 by 2 plus c. Yes, that is the formula. So if I take minus common, it becomes 1 by root 2 whole square minus v square dv, right? And you see here, you just need substitution. This is same. So in this part, let's apply formula minus 1 by 2. And what is it? 1 by 2a. So 1 by 2 times 1 by root 2. Right? Log of a minus x. So 1 by root 2 minus v divided by 1 by root 2. Okay, this is plus v, this is minus v. Minus 1 by 2. Achha. Now in integration of this, you just have to substitute this denominator as t. So put v square minus 1 by 2 as t. So it implies 2v is equals to 2v dv is equals to dt. So it becomes dt divided by t is equals to log x. Let's solve this. This is root 2, so it becomes minus 1 by 2 root 2 log of 1 plus root 2v divided by 1 minus root 2v minus 1 by 2 log t, which means v square minus 1 by 2 is equals to log x plus log c. Don't forget to substitute all the values here. When I say substitute all the values, you just don't need to do this part. You have to substitute capital Y and capital X also. Capital Y and capital X are from here. Capital X is small x minus h. So it is small x is small y minus k and small x minus h. Now what is h and k? H is 1, k is minus 1. So h is 1, k is minus 1. So every v need to be replaced by this. That will be your answer. Okay, don't leave it over here. Next. Question number 5. Chalo. Try this question now. Okay? It's exactly the same. We'll move ahead. Question number 6. Try this. Here, it can be reduced to the homogeneous, but there is a small problem. This x and y already means, sorry, these x square and the outside xy also. See how we'll tackle that. First of all, just because of that x square, this x will not create any problem because we have x square. Otherwise, it would create problem. Because otherwise, if I just have x and y, then if I multiply x inside, I'll not get linear equation in two variables. Right now also I don't have linear equation, but a small substitution can make it in the differential equation which can be reduced to the homogeneous. What is that? Put x square as u and y square as v. So 2x dx is du and 2y dy is dv. So differential equation becomes this x dx. Now you can substitute du by 2 here also, dv by 2, and that 2 you can take here in the 0. So becomes 2x square. So 2u plus 3v minus 7 du minus 3u plus 2v minus 8 dv is equals to 0. Okay. So what is du by dv? It implies du by dv is equals to 3u. Now you look at that differential equation. Now you know that it looks like an equation that can be easily reduced to homogeneous. Put small u as capital U plus h and small v as capital V plus k. Tell me value of h and k quick. Therefore, du by dv is equals to 3u plus 2v plus 3h plus 2k minus 8 2u plus 3v plus 2h plus 3k minus 7. Tell me what is the value of h and k. Yes, that's correct. Good. Value of h is 2 and k is 1. We don't need that in the calculation, but at the end when we back substitute the values, here I need h and k. Right? So for h and k, differential equation becomes du by dv is equals to, you take u common here, so 3 plus v common. So 3 u by v plus 2 divided by 2 u by v plus 3. Now put u by v is equals to, let's say, t, or u is equals to tv. So du by dv is equals to t plus v dt by dv. Substitute t plus, obviously the role of the variables are changed here, so don't get confused in that. It's still the same. d v dt by dv, and this becomes 3t plus 2 divided by 2t plus 3. So v dt by dv is equals to 3t plus 2 minus 2t square minus 3t divided by 2t plus 3. So this gets cancelled. 2 common, 1 minus t square. So 2t plus 3 upon 2 common, 1 minus t square dt is equals to 1 by v. Now this can be solved again. Yeah, again, one part will give you a square minus b square, because when you separate with this, then you just need to substitute denominator as some new variable. And for this part, you get that same formula, 1 by a square minus x square log formula. So solve it, and now answer would be substituting everything. Like t, you will first of all substitute this. T will be substituted as u by v. Then u will be substituted as small u minus 2 and small v minus 1 respectively. And then small u and v, small u and small v will be calculated, will be substituted as x square y square. So there are many back substitutions you have to do. Finally, you will get answer x square minus y square minus 1 raised to power 5 is equals to c x square plus y square minus 3. But at the same time, please note that answers may vary. Why the answers vary in differential equation? Because the simplifications. You see, even just uh, over here in this expression, you end up having a log term. So this will give you log, this will give you log. We try to, if you try to eliminate log by taking log c as a constant and converting every term to log, then you can cancel log. But if one decide not to take log, then the log will be there. Right, if you just take c over here, the log will be there. You'll not be able to eliminate log. So maybe you end up with an answer where log is there. So it doesn't mean that it's incorrect. Only the simplification of the solution may differ. So even if you check, even if you do some questions from the book and you see that, okay, this is not coming out to be the answer. So please check that at least you are going through the same process. No mistakes in the calculations and all, but your answers may vary. There's no problem in that. Okay? Answers may differ. Next come the most important part of this. So this I will say method 2A. Right? All right. So next is the method 3. This method is so far the strongest method from the last few methods that we have seen. The first two methods and the reduction methods that we have seen. So total, if I calculate the reduction part also, so total 4 methods I have seen. So this method is the strongest one. इसको हम लोग क्या शस्त्र ब्रह्मास्त्र बोलेंगे, ठीक है. बट एट द सेम टाइम टू अप्लाई ब्रह्मास्त्र इज नॉट वेरी piece of cake, है ना. It will involve so many complex calculations sometimes, right? So because to actually use the brahmastra, it's not possible. It's very heavy and all those things. So similarly, this is heavy, but if you apply that, your question will definitely be solved. Okay, so that's why it's lengthy also. We have some sub parts also. So Let's see. First of all, just like homogeneous differential equation, first you figure out that whether you can apply such kind of method, whether this is homogeneous. If it is homogeneous, then we apply the method that is used in homogeneous. Similarly, first I'll figure out whether it is exact differential equation or not, and then I'll apply the methods to solve the exact differential equations. Okay, so so if m and n are the functions of x and y, the equation this is called exact when there exists a function of function f of x y of x and y such that d of function f is m dx plus n dy. I know that you know the condition of, if you have done exact differential equation, then there is a condition of del m by del y is equals to del n by del x. That is there, but that's the second thing. That's the property that comes out from this. Actual definition is this part. So if you want to say that this is exact differential equation, then this can be written as the differentiation of a function, total differentiation of a function. In total differentiation, the difference between differentiation and total differentiation is only that you do not write with respect to what you are doing the differentiation. Every variable is your variable. Means if I'm, let's give an example, total differential or total differentiation. So if I want you to do total differentiation of, let's say, xy, xy. So you don't need to ask that y is a variable or x is the variable. In total differentiation, it doesn't matter. D of xy. First of all, we don't write with respect to what. D of xy is keep x as it is. Differentiation of y is dy plus y as it is. Differentiation of x is dx. This is the total differentiation. And this is also the perfect example of what I'm trying to explain here as an exact differential equation. You can so if I'm solving, so if you have a differential equation like x dy plus y dx is equals to 0, just compare it with this part. So I can say that this is exact differential equation. Why? Because this can be written as total differentiation of a function of xy. Okay, that's why this is exact differential equation. But just to look at this expression, if you do not know this part, it will be sometimes difficult to guess that it is a total differentiation of which function xy. Means basically I have to find that function f. If I'm able to find that function f, then I can say it is an exact differential equation. So every time we'll not be able to make, just hit and trial method, but still we have few formulas which you have to memorize in order to check the exact differential equation, right? uh, let's not talk about this. I'll talk about that at the end of that exact differential equation, because that is the least thing, uh, least required method. I'll apply it only at the end. When nothing works, then I'll apply it. So basically what I want to say is thinking about this xy all at once will not be possible here. Even if it seems very obvious, not every time it will be obvious. Okay, so we need some other method by which I can check exact differential equation. That is easy to see also. So this is the condition. The necessary and sufficient condition for differential equation this to be exact is this. So this is the condition: del m by del y is equals to del n by del x. Make sure to make the correct comparison with the differential equation. The one with the dx is m, the one with the dy is n. If this is m and n, and del m by del y is del n by del x, then you say it is exact differential equation. Now you do not have to find that f. Okay. So what is the solution? Best part about exact differential equation is first you check this condition. If it's satisfied, it is exact, and you can directly write the solution. You don't need to solve to get to this solution. Okay? This you should remember. The solution is you integrate m with x, keeping y as constant, plus integration of terms of n not containing x, not containing x, dy is equals to constant. That is the solution. Let's solve a question. So first we'll try to only apply the formula. So that's why I'm taking only the equations which are exact already. Then we'll see how to reduce it to exact if it is not exact. Question number 7. Solve x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equals to 0. If you compare it with m dx plus n dy is equals to 0, then you get the value of m and n. Find out del m by del y and del n by del x. See whether they are equal or not. Yes. Same. So this is going to be, if you differentiate it with respect to y, minus 4x minus 4y, and here with respect to x, minus 4y minus 4x is the same. So what is the solution? Therefore solution is integration of m dx, y is constant, plus terms of n, terms of n not, terms of n not containing, not containing x, dx, dy is equals to constant. So let's see, y is m is x square minus 4. To avoid the confusion, you can actually substitute y is equals to a constant also, and you can then back substitute, means you can write it as 4kx minus 2k square, so that you know that that is a constant, right? Dx plus, you have to choose terms of n in which x is not there. Only the first term does not contain x, the last two terms does. So it is y square, integration of y square dy is equals to c. It's x cubed by 3 plus 4 2 kx square minus 2k square x plus y square by 2 is equals to constant. Okay, that's a solution. Substitute this k as y again. So this answer is x cubed by y plus 2x square y minus 2xy square plus y square by 2 is equals to constant. That's your answer. That's y cube. Yes, yes, that's correct. Y cube by 3. So this is your answer. Right. Next we have working rule for solving. So the exact same thing is given here, and this is the solution. Try one more question. First, tell me what is your del m by del y and del n by del x in this question. I was hoping actually if someone will note that or not. That's correct actually. Yes, absolutely correct. Beta, this was a homogeneous equation as well. So if you have checked, the first is a variable separable. Obviously, it's not variable separable. The way the variables are involved with each other, x and y. So we cannot separate them. But it is homogeneous. That's correct. So simply by homogeneous also you can solve it. Homogeneous also. Good. Solve x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy equals to 0. Yes. Okay, just a second. I've written the last question, right? I'm sorry. Sorry, not this one. I've written the exactly last question. That's correct. Let me correct that. It's 4x plus 3y plus 1 dx is equals plus 3x plus 2y plus 1 dy. And now this should first of all remind you reduction to the homogeneous. You can reduce this equation to the homogeneous, right? But just to apply, let's find out it is exact or not and tell me the answer. Quick. All right. So del m by del y, comparing this is m, this is n. Del m by del y is equals to del n by del x. That is equals to 3. Okay. And solution is also very easy. So you note that even if it was reducible to homogeneous, checking the exactness and when it comes out to be the exact, then to solve it and to get to the solution is much more easy. Time, you save the time also and space also to get to the solution. So solution is going to be 2x square plus 3xy plus x plus y square plus y is equals to constants. That's your solution. Question number 9. Solve this. M is equals to m dx. So m is equals to 1 plus e to the power x by y del m by del y. So that is with respect to y we have to do. So e raised to the power x by y as it is and minus x by y square. And n is equals to e raised to power x by y 1 minus x by y del n by del x e raised to power x by y as it is and differentiation of this with respect to x. So it's minus 1 by y. plus 1 minus x by y as it is, e raised to power x by y as it is, times 1 by y. So it's minus e raised to power x by y divided by y plus e raised to power x by y divided by y minus x e raised to power x by y divided by y square. So this gets cancelled and you end up having the same expressions. Since always try to solve the questions with me. ODE is something where uh, you do maximum number of questions. There's no theory, nothing else. So every question will teach you something new. Maybe in the case of some new approach to solve the integration, and it's not like you don't know that, but it's the high time when you revisit all of them. So uh, when I'm solving a question, you try to solve it with me or to get the solution. So since del m by del y is equals to del n by del x, therefore differential equation is exact and solution is given by integration of m is 1 plus e raised to power x by y m dx plus integration of. Acha, now look at this. First of all, there are two terms in n, but don't confuse this and this is not the two terms. We have multiplication between them. Terms are not separated by multiplication, terms are separated by plus and minus. So if I multiply this, e raised to power x by y, that is the first term, minus e raised to power x by y, that is the second term. But I cannot write any of them because both have x in them. So that's why it's 0. There is nothing over here. Is equals to constant. Right? Here you have to keep your y as constant. Y is constant. So x plus e raised to power x by k, and we have to divide by the differentiation, is equals to constant. It implies your answer is x plus y e raised to power x by y is equals to k. Next, question number 10. X dy plus y dx x square plus y square is equals to a x dy minus y dx. Here you have to separate x and y, dx and dy actually. So coefficient of dy is x square plus y square minus ax. This is coefficient of dy plus coefficient of dx is y x square plus y square plus ay dx is equals to 0. Okay. What is del m by del y? So this we have to differentiate with respect to y. 2xy and del n by del x with respect to x. 2xy. Since del m by del y is equals to del n by del x, therefore differential equation is exact. It implies solution is given by integration of x y is equals to k. X square plus k square. Let me open the bracket also. This is x cube plus k square x minus ax dx. Term of, so first term is y and x square. It has x, but the second term is y cube. It does not has any x, so it's y cube. Y cube dy is equals to constant. So this becomes x to the power 4 by 4 plus k square x square by 2 minus a x square by 2 plus y raised to power 4 by 4 is equals to constant. You can take that to be c1 and you can adjust that constant. So it becomes x raised to power 4 plus y raised to power 4 plus 2 x square y square minus 2 a x square is equals to some constant. Yes, that's correct. There is a last term also not containing x. This last term also does not contain x, so ay. So it will be ay square. Yes, ay square by 2 is equals to c1. So I'll have plus 2ay square. Okay, it's constant. That is your answer. Solve a question in terms of question number 11. This is solve r plus sine theta minus cos theta dr plus r sine theta plus cos theta d theta is equals to 0. It is in terms of r and theta, but the theory is same. So you can take this as m dr plus n d theta is equals to 0. So del m by del theta and del n by del r. Find out. r square by 2 plus r sine theta minus cos theta is equals to constant. Beta, that is your solution. Okay. Now, what is an integrating factor? Beta, integrating factor, yeah, integrating factor is a very useful tool if your given equation is not exact differential equation. If given differential equation of first order and first degree is not exact, so what happens is m dx plus n dy is equals to 0 is not exact. Then definitely del m by del y will not be equals to del n by del x. Simple. It can always be made exact by multiplying by some function of x and y. Such a multiplier is called an integrating factor. We shall write IF for integrating factor. So before that, note that if m dx plus n dy is equals to 0. For example, this is not exact. And now I got a function which is known as integrating factor. If I multiply, so if there is a function of x and y, I multiply, obviously the multiplication will be both sides. Otherwise, my equation will change. I want to solve the exact same equation, so I have to multiply it on the right hand side also because the right hand side is 0, so that does not affect. So first, there should not be any confusion that we are solving some other differential equation. It is not other differential equation, it is just the other form of the given differential equation. So solution of this is exactly the solution of this. All right. And now we have chosen this f in such a way that if I take this new part to be m1 and this new part to be n1, now del m1 by del y is equals to del n1 by del x. So now it is exact, and now you can solve it. But as I was saying in the first part as well here, when we were talking about that f, it's not easy to think about that f now. Okay, you can't just hit and trial methods and you can try some functions to make it exact. It's not the case. We have some rules to find integrating factor. So now this part is, I can say, starting of the method 3a part, where the given equations are not exact but we are trying to make it exact. While we are trying to make it exact, I need to find a function f such that f of, if I multiply f, then I'll get, if I multiply f, then I'll get my, yeah, I'll get the exact differential equation, right? But to find that function f, we have 6 rules, in which the first rule I want to always keep in the sixth, as the sixth rule, because this is the last thing I want to apply. The reason being, it involves so much of formulas to remember. That's why all of them you should remember till 16th. So that's why here it is written as rule 1, but you don't try this method to find out your function f, to find out integrating factor the first time. You will try with the second rule, third rule, fourth rule, and then you will come to this one. Okay, but let's start. If you want to write down this, obviously you will write down this in your formula list, where you will remember this. So d, what we have done, yeah, this we have done, right? You can verify anything like this formula. So forget about this. You can try finding this by yourself. This is what question formula will be applied. Y as it is, differentiation of x square will be 2x and multiply by dx, minus x square as it is, differentiation of y is dy divided by y square. And it is exactly this. Okay, so you can verify. All are same, but the problem starts when you have to think the other way around. Like from the left hand side, you can find right hand side. But problem is from right hand side, how can you guess that y square by x? Okay, chalo. We'll discuss this rule right now, but you know that this is the last preference for finding the integrating factor. Let's try a few questions. Question number 12. Solve this and okay. So first of all, separate, find out m and n. What are m and n? This is 2x y square plus y times e raised to power x dx plus minus of e raised to power x dy. So here you have m and n. First, you make sure that it is not exact. You calculate del m by del n, del m by del y. It will not come out to be equals to del n by del x. So that's why the equation is not exact. If it is not exact, open it. 2xy square, there is no formula, nothing. What we are doing here is dx minus e raised to power x dy is equals to 0. This is not exact. But can I try to merge? This is x dx. But what we are trying to do here is we are trying to apply the original definition of the exact differential equation. This was not the original definition. Definition, what was definition? If this is a exact, then I can write it as d of some function. Now I have to think about that function. Okay, so what we can do here is uh, to, you divide y square because this part actually, this part where you have e raised to the power x reminds us about this formula where we I need y square in the denominator, so just divide y square, so it becomes 2x dx plus y e raised to power x dx minus e raised to power x dy divided by y square. Thinking about that you have to divide by y square will only comes if you have all the formulas in your mind and it reminds you about that formula. So now I got that total differentiation part. This is d of e raised to power x by y. So it's 2x d of x plus d of e raised to power x by y is equals to 0. Now you can simply integrate. To do that, please note that, can you tell me the answer of this? Integration of 2x dx and integration of x square dx square. Tell me the answer. Okay, nice. That's why I have written this. Beta, when you do this difference, acha, you can add one more part here. Integration of x square dx. This is obviously x square by 2. This is x cube by 3. And what is this? Just compare it with the first one. Because here integration is not with respect to x, integration is with respect to x square. So you can simply make a substitution also. put x square as y. So it will take exactly this form. So it is nothing but x square by 2. Compare it with the first one. X raised to power 4. You know? X raised to power 4. Because it was x square square by 2. So when we have d of this, what will be d of, if I integrate, chalo, if I change 1 of d of x is what? X. So what will be 1 of d of x square? X square. So what will be integration of, this is only one variable, so here I don't have to do anything, and this is d of e raised to power x by y, this is 1. So what will be the answer? This is x square plus this is e raised to power x by y is equals to constant. When we are doing integration, is constant. That is your answer. And note that I have not applied the formula of the solution here. This formula that I was applying, this part, I'm not applying that because I'm not going to the path where I'm checking the differential equation and then I'm applying the solution. No, I'm not even checking this part. After getting the equation, I am already trying to make it a differentiation of a function using the original definition. So once I have checked that it is not exact, right, then I have what I have done here, I have multiplied by 1 by y square. So you can say that 1 by y square is the integrating factor here, and once I multiplied by 1 by y square, I got a equation which is exact. This equation, if you will check by the method del m by del y and del n by del x, then you can see that this is exact, that is coming out to be same. And then what? Then you can try finding the solution directly. But in the process, have you realized that where does that 1 by y come from? This was the trickiest part. 1 by y square, we thought that it reminds us of the formula. So that's why I have divided by 1 by y square, or have multiplied by 1 by y square. Okay. So there was no actually a formula by which I found this integrating factor. Integrating factor was 1 by y square. That just came from the formula. So if you go by this way, that after multiplying you are checking the exactness, then you can apply the solution. But I haven't done that. That will also give you exactly the same solution. What I have done, I got the differential equation which is exact, so I'm trying to write it in a total differentiation, which is possible to write here very easily. Okay. Next. So this part, in this particular part, you need some practice. Uh, Keep these formulas in front of you and try to apply them in the question. Question number 13 is, next question is y dx minus x dy plus 1 by 1 plus x square dx plus x square sine y dy is equals to 0. Write down this question. We'll solve it after a break, and then I'll take you to the all those formulas that we had. You can write it down. Done? Chalo. So these are the formulas. If you want to write down, please do. Let's have a break. All right, let's start. Okay, so let's see a few more questions in this part. Yes, this question, right? Okay, so look at this part first of all. Y dx minus x dy. First of all, please check that whether it is a exact differential equation or not. So it will turn out to be not an exact differential equation. So then we'll try to make it exact by multiplying by 1 by x square, because this reminds us of the formula where we have divide by x square. So this is y dx minus x dy divided by x square, plus this will this will not be affected because it's just a function of x, plus now it the last is just a function of y. So So what is it? It is minus of d y by x, right? Because that is actually x dy minus y dx. Plus, it's just a function of x here. So that is what? That is minus 1 by x and then plus x. And here it will be minus cos y is equals to c. So, and the differentiation of this will give me y minus y by x. So that is your solution. Minus y by x minus 1 by x plus x minus cos y is equals to c. So x square minus x cos y minus y minus 1 is equals to cx. That is your final solution. So what was integrating factor here? Integrating factor was 1 by x square here. Question number 14. Question number 14. X cube plus x y square plus a square y dx. I'm missing that part here in the solutions where I'm checking that they are exact or not. So you can do that. It will turn out to be not exact. Then we'll move ahead exactly like the same. X square dy is equals to 0. Now what? Now, first of all, if I open this, x cube dx plus xy square dx plus a square y dx plus y cube dy plus yx square y dy minus a square x dy is equals to 0. What can be done over here? You can combine these two. It actually makes a formula where x can be taken common, and here, not here, this here y can be taken common. And if you do that, what you're left with, if you take x common, it is x square dx, x square plus y square dx, and this will be y common, so again x square plus y square dy, plus in this part and this part you can take a square common, and it is y dx minus x dy. So this makes a formula if you divide it by x square plus y square. So now it becomes x dx plus y dy is equals to plus a square y dx minus x dy divided by x square plus y square is equals to 0. All right. Now you can integrate. This is x square by 2 plus y square by 2 plus a square. This is the total differentiation of tan inverse of x by y. Right. Tan inverse of x by y. So this is equals to constant. That's your answer. Next, let's try this question. Question number 15. Look at this question. Question says x squared dy by dx. Okay, so if you distribute, this is x squared dy plus xy dx plus square root. This square root part reminds you about one formula. There's only one formula that has this kind of expression, which is last one, I guess. Yeah, sine inverse xy. But this is a denominator, so you have to divide it by this, and the numerator is x dy plus y dx. So if I take x common, I get x dy plus y dx plus square root of 1 minus x square y square dx. So I have to divide by x multiply by this root factor. So if I divide, I'll get x dy plus y dx divided by this root 1 minus x square y square plus this is 1 by x dx is equals to 0. Okay. Now you integrate. This gives you sine inverse xy, and this gives you log of x. These are the kind of questions which I think you should do once again also, or try extra questions from this part. Sure. That is it for this part. For rule 1, enough questions. This is the method that you will apply when none of the other works. Now let's see what are the others. The others also, starting from rule 2, you will try to apply them in the exactly same order. First you'll try rule 2, then you'll try rule 3, rule 4, rule 5, because simultaneously this also gets complex. These rules also get complex. So that's why follow this sequence. Rule 2 says that if you have such kind of an equation, which is first of all not exact, then only then we are trying to find integrating factor. So it is not exact. Acha. But it is homogeneous. And mx plus ny should not be equals to 0. Then 1 by mx plus ny is an integrating factor. This is giving you directly the formula by which you can make it integrating factor. Let's see a question. Question number 16. First, you check whether it is exact or not. M dx plus n dy is equals to 0. But it is not exact. Okay. So del m by del y is equals to, with respect to y, it is going to be x square minus 4xy. And with respect to y, it is going to be minus 3x square plus 6xy. Obviously, it's not same. Since del m by del y is not equals to del n by del x, therefore, differential equation is not exact. Okay. Next, if it is not exact, then what I have to check is that a homogeneous. So homogeneous means you just check the index of every term in m also and in n also. In m, the index is the power of x is 2, the power of y is 1, so index is 3. Same index is 3 here, 3, 3. So yes, it is homogeneous. Okay. Now, now 1 by mx plus ny. If it is a homogeneous, then you can first try. This part is done. Check whether this is 0 or not. Given given differential equation is homogeneous. Is homogeneous. And what is mx plus ny? M is x square y. So it's x cube y minus 2x square y square. Then minus x cube y plus 3x square y square. Cancel out. It becomes 2, not 2, x square y square. And definitely it is not equals to 0 for all the values. So that's why I can do the reciprocal. Now 1 by mx plus ny by rule 1, which is 1 by x square y square, is integrating factor. So what this will do, if you multiply your equation with 1 by x square y square, your differential equation will now become exact. Yes. So differential equation becomes, this is x square y minus 2xy square divided by x square y square dx minus x cube minus 3x square y divided by x square y square. This is dy is equals to 0. Square. Dy is equals to 0. So this will become 1 by y minus 2 by x dx minus x by y square minus 3 by y dy is equals to 0. Okay. Now this is your new value of m and n. Find out del m by del y is equals to del by del y of this 1 by y minus 2 by x. It's going to be minus 1 by y square. And what is del n by del x? This is with respect to x. So minus 1 by y square, this is 0. So it is same. Equal. This is now exact differential equation. So you can find the solution. So solution is integration y is equals to constant. This is 1 by k minus 2 by x dx minus terms of n not containing x, 3 by y. So integration 3 by y dy is equals to constant. So with respect to x, that will be x by k, so x by y, and with respect to x this becomes minus plus 2 by x square, right, plus 3 log just a second, this is 2 log, yeah, minus 2 log x minus 3 log y is equals to c. You can leave the answer over here. That is your answer. Yes, beta, that is plus. That plus is from the question itself. Okay. Rule number 3. So rule 3 says, rule 3 says, if your function, if your differential equation is not exact and it is of this form, look at the form first. That means by taking y common, what you are left with only the functions of xy, and taking x common along with the dy, you are only left with xy function again. And this should not be 0, obviously. So 1 by mx minus ny is an integrating factor this time. So let's try a question. Question number 17. y1 plus xy dx plus x1 minus xy dy is equals to 0. Do check that part. Del m by del y is not going to be equals to del m by del x here. Okay, just do check that. After that, what is integrating factor? Integrating factor, acha, it is already written in this form, so I don't need to check anything else here. It's y dx common, the function is in terms of xy. X dy common, the function is in terms of xy. So integrating factor is 1 by mx minus ny, which is 1 by mx. So xy plus x square y square minus xy plus x square y square. So it becomes 1 by 2x square y square. Okay. So this is our integrating factor. So differential equation becomes, you have to multiply this with your differential equation. Differential equation becomes 1 by 2x square y square of y1 plus, or let me, y plus x square y, xy square dx plus 1 by 2 x square y square of x minus x square y dy is equals to 0. So 1 by 2x square y plus 1 by 2x dx plus 1 by 2xy square minus 1 by 2y dy is equals to 0. You can check the exactness if you want, but there's no need to do that because we know it is going to be. So you can write the solution. Solution is integrating of this, keeping y as constant. So 2kx square plus 1 by 2x dx plus integration not containing x term. So it's minus 1 by 2y dy is equals to constant. So this is minus plus 1. So it's minus 1 by 2yx plus 1 by plus 1 by 2 log x minus 1 by 2 log y is equals to some c dash where you can adjust this 2. This is minus 1 by xy plus log x minus log y is equals to constant. You can leave it over here, or you can find the find you can try to eliminate that log part by taking this as log c. How can you eliminate this? Becomes e to the power, because this is log e to the power minus 1 by xy plus log x minus log y is equals to log c. So x is equals to c y e raised to the power let me e raised to power 1 by xy. That is supposed to be e raised to power minus 1 by, but that would be in the denominator, so that's why. This is only not like you have to give it this form. You can leave it before also. Next question. Question number 18. Again, y is already common here, y with dx and x with dy. You can see xy, 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 and xy is the function. So definitely rule number 2 can be easily applied. M is equals to y, xy, sine xy. You can check the exactness here. That will not be exact. Plus cos of xy. And n is going to be again x times xy sine xy minus cos xy. This is plus. So what is going to be the integrating factor? Let's find out mx minus ny. That is going to be just multiply x square y square sine xy plus xy cos of xy minus xy square sine of xy plus xy cos xy. So this gets cancelled and becomes 2xy cos xy. This is your, so with the help of this, integrating factor is 1 by 2xy cos of xy. Multiply with this differential equation, obtain a new differential equation that will be exact definitely. So your solution would be, log of secant, I'm fine, like I'm writing the final answer, log plus log x by y is equals to log of c. So c is going to be x secant xy divided by y. That's your solution. Complete this till your solution. Next we have rule number 4. Look at this rule. If this part is a function of x alone, that means there should not be any y. Then this is the integrating factor. Then this is an integrating factor of your equation. So let's do a question. Question number 19. Solve y plus y cube by 3 plus x square by 2 dx plus 1 by 4 x plus xy square dy. So what is del m by del y? You can find out because this is going to be 1 plus y square, and del n by del x is going to be, do check the exact part always. So 1 by 4, 1 plus y square, and it is obviously not same. Since del m by del y is not equals to del n by del x, therefore differential equation is not exact. Now consider, what was it? 1 by n del m by del y minus del n by del x. I have also calculated del m by del y and del n by del x in this question because I needed that in integrating factor. So that's why I showed that it is differential. It is not differential. It is not exact. I haven't shown in the last few questions, but you have to do that. So consider this is equals to, what is n? This minus this, 4, 4, 3, 3 by 4, and 3 by 4, and 1 by. So 4 cancels, 3 by x. That also cancels. So yes, this comes out to be exactly the function of x. There is no y here, so I can say that my integrating factor is e raised to the power integration of this function. Function is 3 by x dx. That is equals to e raised to the power 3 log x. That is equals to e raised to power log of x cube, and now you can cancel e and log. Your answer is x. So you just, differential equation becomes, you just multiply x cube throughout your differential equation. So that will become x cube times y plus y cube by 3 plus x square by 2 dx plus x cube by 4 x plus xy square dy is equals to 0. right? So check the exactness. It is exact. So solution is going to be y is equals to k x cube k plus k plus k cube x cube by 3 plus x raised to power 5 by 2 dx plus here there is no term except x because x is multiplied, so every term has x, so it's 0 dy is equals to c dash. So simplify, answer is going to be 3 x raised to power 4 y plus x raised to power 4 y cube plus x raised to power 6 is equals to constant. Okay, now question number 20. Yes. First, again, check del m by del y and del n by del x. They are not going to be same. Then you find 1 by n del m by del y minus del n by del x. That will come out to be a function of x. Integrating factor would be e raised to the power integration of fx dx. That's correct. That is coming out to be x. Correct. So your differential equation becomes, let's multiply x multiply x square plus y square plus x dx plus x square y dy is equals to 0. Right? Solve it, it will come out to be, so this is a differential equation and solution will come out to be y is equals to constant x cubed plus k square x plus x square dx plus 0 dy. There is no term not containing x, so that is equals to constant. So it is x raised to power 4 by 4 plus x square y square by 2 plus x cube by 3 is equals to c dash. So 3x raised to power 4 plus 6x square y square plus 4x cube is equals to c. That is your solution. Try this question with rule number 5. As you can see, now it has to be if only function of y, then e raised to the power integration of fy dy is your integrating factor. Try this. Any answers? Great. So beta integrating factor you can find out from here. That will come out to be 1 by y raised to the power 4, right? And I'm directly writing the solution. Solution would be x square e raised to power y plus x square divided by y plus x divided by yes, complete. It would be 0. This is equals to the answer. You have only one integration to do because the second integration with respect to y is 0 because there is no term of n without x. That is your answer. 22. Acha. Now look at this. Starting from rule number 2, there should not be any confusion that which will be applied in the question. Let me tell you why. Because second and third rule has a proper form. Second has homogeneous. You check, matlab, without even doing any calculation, just look at the differential equation. If it is homogeneous, then I can try finding mx plus ny. If it is non-zero, my job is done, and it does not require much of a calculation to find mx plus ny, right? Next, if it is not homogeneous, the rule number 2 is already discarded. Taking y common, taking x common, here also you do not need to actually write the equation by taking x and y common. You can just see the equation, and without doing any calculation, if you see that okay, this is a function of xy, two functions of xy, then you can just find mx minus ny. If this is not 0, then 1 by mx minus ny is an answer. Okay. Acha. In the next two, in the next two also, it's easy actually. Once you see that it is not a differential equation, obviously you have calculated already del m by del y and del n by del x. Subtract, divide by n. Here, subtract, divide by m. Also, this is getting the point. I don't think that we'll have a. It's not like I have to apply rule 1, then rule 1 doesn't work, rule 2, then rule 2 doesn't work. We will not apply rule 1 and rule 2 and rule 3 because I don't have the required form. This e raised to power y, first of all, eliminates the possibility of homogeneous. Homogeneous we only check for polynomials. Yeah. This is non-homogeneous, right? So that goes on. Acha. Now with x, first of all, can I take y common? Obviously, I can take y common. But after taking y common, do you see that we have x, y? No, we have x, y cube. So third rule is also discarded. Fourth. Fourth will come from the fact that you just find out this. And after finding this part, you can realize that whether it will come out to be the function of y or x, depending upon you are dividing it by n or m. Right? Look at this. Homogeneous is gone, right? Because this is 3 and this is 2. Index 3, index 2. Acha. Next, if I take y common, I cannot take y common. Rule 3 is discarded. And then you have to find again the same del m by del y and del n by del x. So that will not come out to be same. Rule 2 and rule 3 are already discarded. So we have to subtract them. Find out. It will be a function of y alone. So integrating factor would be e raised to power 6 y. I'm writing the solution. Solution would be e raised to power 6y x square y square by 2 minus 1 by 3x cube plus 1 by 6y square minus 1 by 18y plus 1 by 108. That is equals to 0. That is your solution. Okay. Now rule 6 is the complex one. Okay, the last rule, and you know that we will count is this. The next rule is as rule number 5, by inspection, integrating factor by inspection that we saw in rule number 1, that we will consider as rule number 6. Rule 6. So how this rule 6 works? First, again, you start by the differential equation having the form of mdx plus ndy, and in fact, every differential equation of first degree and first order can be written like this. This is equals to 0 is of the form. Look at the form. Form is x raised to power alpha, y raised to the power beta, my dx plus n x dy is equals to 0. Then integrating factor is x to the power km minus 1 minus alpha, and y, they're in multiplication, x to the power this and y to the power kn minus 1 minus beta. K can have any value. Now what? Just a second. Yeah, so k can have any value here, and now let's try to understand this rule through an example. I'll write the form once again. Yeah, this is the question. Which says y square plus 2x square y dx plus 2x cube minus xy. Okay, so you first discard every other rule. First of all, obviously you will calculate del m by del y and del n by del x. You subtract them, it will not be a function of x or a function of y. So rule number 4 and 5 are gone. It's not homogeneous, and here I cannot take x common, so it's not rule number 3 as well. So every rule is discarded now, and it's not coming out to be exact also. So the last rule that we have is check whether it is of the form x raised to the power alpha, y raised to the power beta, my dx plus n x dy, which is telling you that you take x raised to the power alpha and y raised to the power beta common from the complete. So is it possible? Is it possible? So actually this form can individually work on some parts also. Let me tell you what does that mean. Like here I cannot take, like in the complete part, I cannot take x raised to power something and y raised to power something common out. So instead what I can do, this is dx, this is dy. you can combine a term of x dx and you can combine a term of dy. For example, here this is y square dx, and if I take the last term of dy, this I can combine, plus 2x square y dx plus 2x cube dy is equals to 0. Let's take common. X I cannot take common, so I'll write x raised to power 0. Y I can take common, y raised to power 1. And I'm left with, what is it? I'm left with y dx plus minus 1 times x dy plus x square y raised to power 0 and 2y dx plus x dy is equals to 0. Okay. Now compare with x raised to the power alpha, y raised to the power beta, m y dx plus n x dy plus, but there is one more factor. So I'll rewrite this same expression but with a different choice of these constants. So I can take x raised to power alpha dash, y raised to power beta dash, m dash y dx plus n dash x dy. That is equals to 0. Write down all the values by comparing. What are all the values you are getting? Alpha is 0, beta is 1, m is 1, n is minus 1, then alpha dash is 2, beta dash is 1, m dash is 2, and n dash is 1. So what will be the integrating factor? Integrating factor of this will be different, obviously, because I'm dealing with it separately. So integrating factor will be, this is the integrating factor, x raised to the power, so for the first term, this is for the first term, I'm writing the formula, x raised to power k m minus 1 minus alpha, y raised to the power k n minus 1 minus beta. You have the value, substitute. Achha, k can be any number, so I can write this is k minus 1 minus 0 and y raised to the power y raised to the power minus k minus 1 minus 1, so minus 2. Okay. This is your integrating factor for first term. What will be the integrating factor of the second term? For second term, it is x raised to power k m dash minus 1 minus alpha dash and y raised to power k n dash minus 1 minus beta dash. So x raised to the power 2k minus 1 minus 2, so minus 3, and y raised to the power n dash is 1, so n dash minus 1 minus 1 minus 2. So this is the integrating factor for the first one, and this is the integrating factor for the second one. But if I do multiply this term with some another integrating factor and this with another, then obviously my question will be changed. This is not the same differential equation that we have started with. I have to choose one of the integrating factor that will work for both of them. So that's why if you equate them, you will get the value of k. So k minus 1 is equals to 2k minus 3 by equating the coefficient of, by equating the powers of x. So it is k is equals to 2. Right? Okay. Just a second. Just a second. This is K dash. This time here it will be K dash. Okay, so K minus 1 is equals to 2K dash minus 3. So K minus 2K dash plus 2 is equals to 0. And second is minus K minus 2 is equals to K dash minus 2. So minus K minus or K plus K dash is equals to 0. I think I have done something wrong. बीटा डैश जीरो नहीं होगा ना, बीटा डैश तो वन होगा, यहाँ तो वन ही है. अच्छा नहीं, नहीं y raised to power 0. Yes. This is 0. This will be dash. K dash minus 1. K dash minus 1. Yes, now we can solve it. So it is K plus K dash. So plus 1 is equals to 0. Okay. Solve them. Yes, the value of K is coming out to be minus. Just solve this question, okay? Find out K. You have two equations in two variables. Find out K and K dash. Substitute either the value of K here or the value of K dash here. You will get exactly same integrating factor. That integrating factor, multiply, you will get exact, find the solution. Completed. If you have any doubt, please do ask me in the next class. We can discuss. Answer is 6x raised to power half, y raised to the power half, minus x raised to power minus 3 by 2, y raised to power 3 by 2 is equals to constant. That's your solution. Okay, and the exact part is done. Now we have the next method, method number 4. That's it for today. Please complete this. Yes, beta. You can actually, I made a video. It's on YouTube, so you can see I have solved the complete paper. You can check out. ODE part I'll upload today, but this analytic geometry is completed, so you can see. Okay. Thank you so much, everybody. Thank you, Acha. Yes, that is tomorrow, right? Yes, tomorrow we have a test. Yes, complete analytic geometry. All right. Thank you so much, everyone.